Hi, this is Mrs. Roble. This is Chapter 11, Part 4 of Stoichiometry. So in this video, you're going to determine the theoretical yield of a chemical reaction from the data that is given, and then you're going to accurately determine the percent yield for a chemical reaction. Okay, so percent yield, you're essentially looking at how much material do you get from your chemical reaction. So for percent yield, you want to look at actual yield. That is what you make in the lab. So if you're doing a reaction, you measure out the mass of your product, and that's going to be actual yield. Maximum yield, another word for that would be theoretical. That is something that you have to calculate. That's not something that you get in the lab. So here's a reaction here where we have oxygen combined with hydrogen to give us water. And they tell us that we have 5 grams of hydrogen and 42 grams of oxygen, and together they are reacted. So if they find out 38.6, now that 38.6 is a clue that you're actually looking at what we call actual yield. So actual yield is right there. 44.9 is what this person calculated based on the 5 grams of hydrogen. So they want to know, what is the percent yield? The nice news is that all you have to do is take this divided by that times 100, and that'll give you the percent yield. So when we look at our equation here, we get 86% based on the data that they gave us. Okay, so here's another example of a percent yield. So we have a reaction where we have 20 grams of calcium and 20 grams of water. So once again, we need to figure out the limiting reactant. So these are equal amounts. And remember, that's based on mole ratio. So whichever one produces the least amount of moles is going to tell you which one's the limiting reactant. So here, if we take 20 grams of calcium and we divide it by molar mass, then multiply it by mole ratio. So notice it's 1 mole of calcium hydroxide to 1 mole of calcium, and then multiply it by 74.09 grams. The maximum yield is 37.3. Now, they have to tell us our actual yield, and our actual yield in this case is 32 grams. So notice that always goes in the numerator. So it's essentially actual yield divided by maximum yield or theoretical yield, and in this case it's 85.8%. Okay, another reaction or another problem that we have is 17.38 grams of magnesium dioxide. So notice that it reacts with an excess of hydrochloric acid. So when they say excess, that means that it doesn't matter how much hydrochloric acid we have. All we care about is the manganese dioxide. So here's a balanced chemical equation. And notice that there's a coefficient of 1 in front of the manganese dioxide. Now they tell us the actual yield. So the actual yield is 4 liters. That must mean that we need to use volume to help us the percent yield. So here we have, once again, the mass that they tell us that we have divided by the molar mass, and then this is multiplied by the mole ratio. So we have 1 mole of chlorine divided by 1 mole of manganese dioxide, and then we're going to use the molar or the volume converter to give us liters. So notice that if we use all of the amount that we started with, this is our maximum yield or theoretical yield. So what goes in the numerator is the actual yield divided by the maximum or theoretical yield. And when we do that, we get 89.2%. Okay, so in summary, when we're looking at theoretical yield, we're looking at what is the maximum amount. If all of our reactant became product, that's what we would calculate. Now the actual yield is something that you cannot calculate. That has to be something that you get measured in the lab. And then just for figuring out the percent yield, all you have to do is take the actual yield divided by the theoretical times 100.